What's the value of that limit on number 18? Well, first of all, let's kind of break it up into pieces and just talk about what it means. This is the limit as n approaches infinity. Now, we can't plug in an infinity because, contrary to popular belief, infinity is not a number. But what we can do is plug in very large numbers for n that are getting closer and closer to infinity, as if we could, and figure out what it looks like it's approaching. So here's my best suggestion. Why don't we type it in the calculator? I'll slide this over here so there's not a glare on the screen. You can see it. Can't see the answer choices, but who cares? We'll deal with that later. So y equals, and I'm going to clear out some things and turn off my scatter plot and whatever else needs to happen depending on what happened last with your calculator. But 3 to the x, can't use n, so minus 1 divided by 3 to the x. Let me warn you, that numerator needs to be in parentheses because it is more than one term. I hope you realize the mistake that I just realized as well. You see it? You see the mistake I made? It has nothing to do with parentheses. It has everything to do with the fact that I left the x pointed out. There we go. 3 to the x. So, what we need to do is plug in large values for n and see what it approaches. It's not enough to plug in one large value. What we need to do is plug in several of them. So I recommend we set the table. So I'm going to pull out my tablecloth here. No, second and table set, and let's set the independent to ask. You can switch this back and forth throughout the exam or whatever you're doing. For now, I think it needs to be set to ask. So we can plug in large values. I just hit second and table in case you didn't see it. I'm going to delete whatever stuff is in there. There's usually things left over from previous things. So we have set that to ask. We've gone to the table. And now we're going to plug in big numbers for n. Let's not get carried away. Let's just plug in, go 10. Now 10's not too big. And that ends up being 0.999998. Clearly that rounds to 1. Let's plug in 100. 1. Interesting. Now, it tells us it's 1, but let's be realistic. It actually isn't 1. If we plugged in 1,000, we'd get an error. There's a reason for that we might get into in just a second. But basically, the bigger the number we plug in, it's going to give us an error in this case because the calculator can't do it. But the biggest thing that we could plug in, that we have tried so far, gave us a 1. And the other thing we plugged in clearly would round to 1. So I'll go ahead and tell you what the answer is, and it's kind of staring you in the face. But I want to show you a different way of doing it, just in case that doesn't work, because there are instances where it won't, where you see you plugged in a big number like 1,000, or in this case 1 times 10 to the 10th, which is an enormous number, and it gave you an error message, so it wouldn't be easy to figure out. So what we're going to do is sort of pick this thing apart and see what we can do with it. This is perfectly legal. This is algebraic manipulation. We want to know what the limit is as 3 to the n minus 1 over 3 to the n for n as it approaches infinity. Now, one of the things I noticed when we look at that is we have one fraction that we can really break into 2. You know, back in the day, a little side note here, back in the day when you were adding fractions, somebody told you that if you had 3 halves and then you added 5 halves to it, of course you got improper stuff, but we'll get over it, then what you really had was 3 and 5, and you didn't add those denominators, you really just kept it as a 2, and so you ended up with 8 over 2, and I mean obviously you can reduce that and get 4. But in this situation what you really had was, let's kind of take this idea and go backwards, you really had 3 to the n over 3 to the n minus 1 over 3 to the n. It's perfectly legal. What I always tell my students is this: 3 to the n is going to go into that, make a fraction out of that. 3 to the n is going to go into that, and you make a fraction out of that one. It's perfectly okay. Well, 3 to the n over 3 to the n is what? 1. So we really have 1 minus 1 over 3 to the n. And now let's start thinking about what would happen if I plugged in a number that's large. If I plug in an enormous number for n, the bigger the number I plug in for n, the larger this denominator gets. When this denominator gets really, really, really big, then this fraction gets really, really small. So big denominator, I'm going to abbreviate here, big denominator means small fraction. Instead of saying means small fraction, I'm going to say that it approaches 0. Well, that's fantastic. So what we really end up with is 1 minus what would be rounded off to 0, so 1 minus 0 is just 1.